Hi, I'm Lee Teschler, Executive Editor of Design World. When it comes to characterizing how power semiconductors operate, there's a new kind of instrument that designers should know about. The typical way of evaluating three-terminal devices such as small signal transistors has been with a curve tracer. A curve tracer basically applies a voltage to two terminals of the device and continuously varies that voltage with time. It measures the amount of current the device passes at each voltage to generate the familiar voltage versus current graph. By sweeping the input voltage or current through a range, the curve tracer generates a group of V versus I curves for each step of the control signal. This group of curves makes it easy to determine, for example, the gain of the transistor. But semiconductor devices have internal sources of energy storage, and these internal sources can degrade the accuracy of the V versus I curves that the curve tracer generates. These effects can be particularly substantial for wide bandgap power semiconductors like FETs, made with silicon carbide or gallium nitride, because these devices sometimes operate at the VHF switching frequencies and at high power levels. As frequencies rise, switching loss eventually exceeds conduction loss, and switching loss strongly depends on the power device's parasitic capacitive elements between the gate, drain, and source, which in turn depends strongly on the drain-to-collector voltage. Another problem is that the conventional test equipment you normally use can't measure capacitance at DC biases greater than 100 volts. So circuit designers traditionally have tried to estimate capacitance at these levels. But that's impractical when the semiconductor device is built with trench or superjunction structures, as you might see with gallium nitride power devices. In addition, complicated manufacturing processes can induce additional variations in device performance. So it's become essential to characterize device capacitance from actual chip and module level measurements. These are all reasons why instrumentation suppliers have developed specialized equipment optimized for wringing out modern power semiconductors. They can work at high bias voltages, and they can also characterize the parasitic circuit elements you find in power devices. These instruments are usually called power device analyzers, and they've been used for years by companies that have manufactured power semiconductors. But it's only been recently that instruments for making these kinds of measurements have been developed with circuit designers in mind. So there you have it. Don't rely on a curve tracer when you really need a power device analyzer. And for more videos, go to designworldonline.com and powerelectronictips.com.